Okay, so I've also got a couple questions about the particle effect. My initial um, hint or recommendation would be that if you can do the brick array and understand the brick array, the particles are really just a smaller brick array. And so if you think about what happened when we created the brick array, um, we're going to be doing a lot of the same stuff. And then we just sort of have to think about where we want to create the array, and how big the particle should be, and maybe what color the particle should be. But in my opinion, that's all information that we're gonna take from the brick that we hit, right? Because the brick that we hit has a color, a location, a size. So let's think about that. So, anyways, I made a class for particle, much like a brick class. In fact, I extended brick, which extends rectangle. I don't know what really difference there is between making a brick versus a rectangle. I guess you have certain things like color as attributes. But anyways, so I made a static particle array called particles, much like my brick array, and I'm going to give each particle a dx dy, and I used a constructor which would allow me to, uh, specify like kind of the width and the height. The width and the height is probably not necessary as an argument. I could probably, uh, yeah. I mean, all my bricks are the same size, so it's really the same thing. Anyways, I also want to just kind of inherit this structure for my drawing the particles. So I have a method to draw a particle, and then in the draw particles, I'm just going to iterate through my particles array and use this method up here. Okie dokie, so let us check this out. So first things first is we probably need something to sort of make the particle array. So let's say particles. Now, in my opinion, we really want to take a brick as a parameter because there's a lot of information that the brick has. Like it has a location for us, just kind of a starting location, and it has a color, which is nice. So in fact, I believe I could just say color. What's the name of the brick? COL. So I should say COL equals, and it's going to be B dot, I'm going to say get color. Is that how to thing? Yeah. So I actually wrote a method to get the color from the brick. And now, the field, oh, it's not visible. Interesting. So I could get the color. I would need a method to set the color. Do I have such a method? Yeah, I do. Oh my gosh. Okay, cool. So yeah, because it's private, what I'm gonna have to do is say, again, this dot set color, right? And the color I'm gonna set it to is going to be the color of the brick. Interesting. Okay. Anyways, so now my particle has a color to work with. And now I need to create an array of bricks or particles. So the question would just now be, how many particles do I want to have? And I'll say maybe you can pick a small amount to begin with, like 40 or something like that. All right. How about that? Personally, I think that, first of all, I'm going to say there's going to be an int x here, which is going to be the location x, right? There's actually a double, so we're going to have to typecast that. And these are just the starting sort of locations for the particle array. Top left corner, right? I'm thinking top left corner. Okay, so we've got these values. Now I need to figure out like the size of each particle, right? And in my opinion, the size of the particle is kind of determined by the size of the brick, right? I'm going to make it like a fraction of the size of the brick. And what I need to do is decide how many particles per row I want and how many rows per particle I want, in my opinion, right? So let's do that too. We'll say, part per row or something like that. I'm going to make it 8, right? And I'm going to say int row or rows per, it's actually rows per particle array, or I'm going to say rows per array. How's that? And I'm going to make it 5, right? How about that? So, I'm about ready to build this thing. So I'm going to say for int I equals 0. I is less than. It's really the size of the particles array. So particles dot length. Right. Okie doke. And so now for particles index I, right, for each location in the array, I'm going to put a brick, or a particle in this case. The location is going to be xy. And I got a lot of xy's kind of floating around, but the xy's I'm referencing here are the local variables xy that I've created, right? That will take priority over anything else. And the width, so the width to me is going to be the width of the brick divided by how many particles I want per row. So I'm looking at b dot get width. Can you just see the width? B dot get width, which unfortunately is a double, and I'm going to divide it by part per row, right? Unfortunately, it's a double, but I can typecast that to be an int. Right? Now, here's the thing, and I say one kind of issue with this is we're starting to get pretty small values, and when they're integers, the values are just going to get smaller and smaller. I don't know would it matter if I turned b.getWidth into an integer and then divided it. I think I might have a better chance to get a slightly bigger value if I divide this first and then make it an int. I could be wrong, but this is just me thinking out loud. All right, so then similarly, the height is going to be the height of the brick, right, divided by how many rows per array I want, kind of thing. So I'm going to say row per array kind of deal. I need a couple of those. How's that looking? Pretty good. Okay, so that's me, populating this particle array. Now, this is all good. It's all good. By the way, in my breakout method, I kind of have art. I'm just gonna leave this here. Let's just take a look at this really quick. So what I did is I wrote here is a way to just kind of iterate through my bricks array. It's like I'm not even playing the game. I'm gonna start testing and debugging this one aspect of it, right? And what I'm gonna do is I'm gonna iterate through the bricks array. I'm gonna set a particular brick to visibility to false, so that when I draw it, you're not going to see it anymore. And then I had a variable here to tell me that I want to start drawing my particles, right? And basically, like if there were no particles there, then I'm going to make the particles using that brick I just destroyed sort of as the reference, right? Actually, I didn't really destroy it. I just made it not visible, right? We've got the sound kind of left over from our thing. I then set that value, draw particle to 1, which just tells me down here that I'm going to draw my particles. And then I start incrementing count. And this is another thing that people have kind of been talking about a little bit. Oh, that's interesting. So I never reset the value. So, count and index are just two variables I made up here. Index is just allowing me to kind of go through this array, and count is allowing me to keep track of time. So I'm saying count mod 6 equals 0, and I don't reset count. I probably want to reset count here just so I get a full second in each location. Otherwise, I'm essentially going to get some sort of fraction of a second. So I'm just going to reset count there. And now here I am incrementing count. And if count is mod 6 is equal to 0, then I'm just going to move over one more spot in the array index and set this to 0 so that I'm ready to make my particles again. The reason I did this kind of thing is because I don't want to be making particles constantly, right? I want to make particles one time and then move the particles, right? I don't have a move particles method yet, so that's going to kind of yell at me a little bit. And so let us just make a method here. And we'll just leave it empty because it's void right now. So, but at least when we come back here, we're not going to get this error message. We are still getting an error message, but it's because we didn't save this. So let's save this. And let's come back here and save the error message. So we do. So it's great. I appreciate that. Why would we do this? Oh, static method. Okay, so yeah, let's make it static. It's dealing with a static object. Same thing here. It's a static object, so it needs to be a static method. Now, that'd be a little confusing, but remember, the whole issue with static is that it belongs to the class, right? So if I'm talking about a static object, but I don't make the method static, then it's like an individual brick would have to call that method. And it really doesn't make sense that the individual brick is going to call a method that belongs to the class and that doesn't belong to individual bricks. So when we have instance methods or whatever, they're methods that individual objects call, right? Meaning, and essentially it's this idea that like it's a behavior that the object is able to perform, right? So and we have a class method or something like that. It's a behavior that the class performs. Since this is an attribute of the class, it makes sense that it's the class that's going to call the method. Hopefully that makes sense. This dot set color. Well, this is interesting. So this is now because cannot make a static reference. Aha. So this is yes. I get you. Okay, so let's take that out of there. What I really want is this particle, right? It's the particle's index I. That's the guy. That is the guy. Still no? Change, get color, sound. Yeah, you can go down a rabbit hole here, and you can start, changing everything to static, but I really don't want to do that. So what I want to do, couple ways to do this. Well, funny. I don't know how I did it before because I didn't do this before, but I'm going to do it now. I'm just going to make this another attribute of the constructor, right? And I'm going to say that color gets set to whatever argument we pass in. Oh. Oh my gosh. I didn't have this problem last time, so I don't really remember what I did. Boom. And let's see that. Okay. Cool. All cool. All right. So let's come back down here, and I want the brick to get the color. How about that? So we are going to get the color of the brick, right? And we are going to pass it in here when we construct the particle as we are here. And then we're going to set the color of the brick. Which I didn't do that last time, so I forget what I did. Okay, so how about that? Where are we at right now? I've got a particle array, 40 items in it. I think I'm populating everything. I've got a way to sort of iterate through it. I mean, I know it's not perfect, but I just want to be able to sort of test it, right? Why can't this? Move static graph to. They're both getting the same. Interesting. I thought I made them both static. Oh, I didn't. All right. How do you like that? We like it. Okay. Yeah, sometimes you're just not saving it, so it's not updating the changes you made. All right. So let's see. And I wrote a move particle method, which doesn't do anything. Basically, what I'm expecting now is to see some bricks, and then 60 seconds later, see some bricks, particles, sort of somewhere else. I'm also getting sound, I guess, still. Sort of expecting to see 40 bricks, right? 40 bricks, but I'm only seeing one brick, right? Now, to me, if you did the make bricks and you understand make bricks, you probably understand why we're only seeing one particle here, right? And it's because we've never changed the location of the other 39 particles we're making, right? So how about each time we say x plus equals, and again, how much? Well, it's really this value, isn't it? Like we're really moving. That's the width of each particle. So we can try that. And it looks like just one big giant brick because there's no sort of space in between any of the bricks. But what's kind of interesting, you probably can't really even tell, is that one row is actually goes way super long. Because we haven't sort of like reset x back. It's like a typewriter almost. When you get to the end of the row, you got to reset it back. So we have to say when we want to reset it back. I don't know. The way I do it, I always get these weird errors. I don't know. There's got to be a better way to do this. But I basically say kind of, n, if n mod, it's really however many part per row is equal to 0. Whenever that happens, I want x to go back to being whatever it was at this point, right? Something in relation to the location of the brick. At one point I had it 0, so it was always like going back to 0, but that actually doesn't really make sense. And then I want y to increase, and y to increase essentially by kind of whatever value this is, sort of the height of the particle, right? How about that? That's going to be the magic, and I need to increment the value in each time. When I don't do this, I always get it to be one too many. I guess instead of using n, I could just use I plus 1. And that seems like a reasonable thing to do. But let's try this. Now it's interesting. Well, it doesn't look like we're getting particles, right? It looks like we're just getting another brick. But we have no space in between the particles, so yeah, so they're right next to each other. So it just looks like a giant brick. When we get movement, we'll start to see that we actually have a bunch of different little particles out there. So now we have to think about movement, right? And basically, I would say that the trick with the movement is, and maybe I should just do something like this and say, we'll just go like this. Well, right now there is no dy dx, right? So whatever. Let's pretend that we set dx equal to 1 and dy equal to 1, and the move particles, we say we are going to have to iterate through the array, right? So we'll say for for I equals 0, plus, let's say, and we'll say particles 1 plus equals dy. All right. They don't like that. In non-static field. Yeah. Okay, let's take this logic. Let's say public vote. Yeah, I did this last time, but I didn't. And I like this abstraction anyway, just because it like breaks it apart, makes it easier to understand, easier to see. So I'm gonna say this dot x equals x y, and this dot y, and then here I can just say particles index I dot move. Yeah. Right. Okay. Now here's the thing. Let's just see what happens. So the problem here is that it looks weird. It's like a brick is moving, but what we're getting here is every single particle has the same dx dy, and it's a constant dx dy, and so it's just they're constantly moving in the same direction. So the answer is to get that sort of shimmering effect that we want, kind of random movement here. I wonder if I'm going to get that same error. I think I probably am. So let's do this. How about for, well, I like it. What do I do? Well, I do all this random stuff. I actually like this just structure. From Python or whatever, just seems super readable to me. So I'm just going to grab this here and just go particles.move, right? Just so we understand what's happening. So I'm just going to iterate through the array to tell every particle to move, and then this move method, I'm going to sort of assign a dx, a random dx, which is going to create that shimmering value. The bottom line is like half the time I want the dx to be positive, half the time I want the dx to be negative, half the time I want half. So I'm going to say, are you guys almost out of here? All right, guys, have a good rest of your day. See you, some of you tomorrow. So how do we get it to happen half the time? Well, math.random is going to generate a value between 0 and 1. So if it's less than 0.5, that's like saying like half the time, right? So if it's less than that, let's make the dx be, oh, sure, thank you. Dx be 1. Otherwise, let's make the dx be negative 1, right? And vice versa, so we can do the same thing again. With the dy, right? All right. So I like that. I like that. So basically, we're using math.random to half the time dx positive, half the time negative. Same thing with dy. Then we set the location of x and have it reflect the change, whatever the dx was. So this is going to really change the way our particles are moving. And this initial, actually, dx dy value is really not necessary. So let's take a quick look at this now. And now we're kind of getting some shimmering behavior like that we might want. And so just a couple other thoughts maybe, but you know, maybe these brick particles look a little big to you, so maybe instead of 40 particles, you go 80 particles. I don't know what happens then. Whoa. It's not quite what I expected. Parker. Oh, I see. Yeah, because we have 8, but in order to get more, we have to make more rows, right? We have to make more rows. So if we're going to change that, then we can make this be. We can make it whatever we want. I guess we can make it 12 and 6. I'm just trying to split the difference. I know it's going to be weird too. It's not perfect now. Yeah, but you're kind of getting the idea. So it'll work out better. Here's probably this was like 72 or some multiple better yet. How about 84? Right. Okay. So I think that's probably a good framework, you know, and then you can make changes to values, or you can make, you know, little tweaks to however long you want it to work. But yeah, so just to refresh, this is really borrowing a lot from the logic that was in brick array. You know, we're making our particle array here, using information from the brick to help us make that array. And then this is kind of a key idea here, to have this move method, which is going to sort of randomly create dx dy values for you. We have a move particles method, which just iterates through the array and has each particle move, and likewise with the draw method. And yeah, this isn't exactly how you're going to have it in your game, but the ideas here are, you know, powerful ideas, I think, in terms of like, you know, being able to dictate time with this count variable, you know, and so, you know, if count is just constantly going, and like before I started had a count mod 6 equal to 0, you know, I don't know where count is, you know, in the beginning, so by resetting it to 0, I'll give myself a full 60 seconds every single time, right?